Hello, my name is Farshad. I'm PhD student at Missouri University of Science and Technology, and I would like to present my poster with the topic of evaluation of polyethylene glycol on thermal and rheological properties of Gilsonate-modified binder. The main idea of this research was to develop thermoadaptive asphalt pavement to accommodate to various climate conditions by mitigating and moderating the common thermal stresses in asphalt pavements and also to mitigate heat island effect in urban areas. For this purpose, we use phase change materials because they can absorb a large amount of energy by keeping the temperature constant, and also they can make a large delay before increasing the system temperature. Another modifier that we used was natural lake asphalt that can be found in different forms like a powder, which is gilsonite. Gilsonite can be quickly dissolved and adjust in asphalt binder and coat aggregate particles. And also it can improve the high temperature performance, but it decreases the low temperature performance. As PCM, we use polyethylene glycol PEG 400. And for the knit binder, we use binder with performance grade of 50 to minus 28. We used PEG 400 with a dosage of 5% and gilsonite with a dosage of 3, 6, 9, and 12%. And the first test that we did was BVR test because we wanted to find the samples that they don't decrease the low temperature performance of modified binder. So we just used the green highlighted specimens because samples containing more than 6% gilsonite decrease the low temperature performance compared to the knit binder. So the first test that we did was glass transition temperature. As you can see here, the lower glass transition temperature is more desirable, and as you can see, the PCM or PG 400 could be beneficial in this term. And also we did thermal stability test because we wanted to find the composition temperature of each specimen. And the interesting results is regarding sample containing 5% PEG 400. As you can see here, for this sample, we have 2 decomposition temperature, but after adding gilsonite, gilsonite could work as a cross-linking agent between binder and PEG 400, and we have just one peak here. And another test that we did was thermal conductivity test. High thermal conductivity is more desirable. You see, after adding gilsonite, the thermal conductivity decreases, but just by adding 5% PEG, thermal conductivity could increase, which is undesirable. And also we did high temperature performance grade for the modified binders. You can see the results, and they are the real super performance grade, and this is the super performance grade. Also, we found a global raw parameter for the samples. As you can see, they are all in the low cracking risk region, which is good. For fatigue performance test, we did LAS test. The first parameter was material integrity. The worst specimen was samples containing 6% gilsonite. Also, we did we found the number of cycles to failure, and you can see the results is table. As you can see, sample containing 5% PG didn't make a big change, but sample containing gilsonite, they made they decreased the fatigue performance of the binder. And another parameter that we found was delta TC. Based on the definition, less negative delta TC is more desirable. You can see here the good performance of sample containing 5% PEG delta TC here is positive. But also for other sample, and delta TC is less negative compared to the NIT binder. And also adding 5% PCM can have a good contribution to delta TC. Because we have limited time, I don't present my conclusions, but it is clear here. Thank you for your consideration.